Alright, so today we're going to start talking about waves. And we would like to understand what a wave is. The key idea is that a wave transmits a disturbance energy and or information without transferring matter. The example that the book gives is that if you wanted to communicate with someone, say in Europe, you could write a letter. That would transfer information via the letter, but it would also transfer matter. The actual letter would go from your hands into their hands. By contrast, if you pick up the telephone and call the person, then no actual material ever reaches from you to that person. But a wave, a disturbance, will travel from you to them very quickly, and they will still get information from you. One of my favorite examples for a wave is the cheer by the same name, the wave. So I'm going to copy this person really quickly here. So here we're going to make a whole bunch of these people. Okay. In the cheer, the wave, each person moves up and down, and then the next person goes up and then down, and the next goes up and down, the next goes up and down, up and down. And in fact, when this guy's up, the next guy might start to go up before this guy goes down. Then this one goes up, and this one goes down, and this one goes up, and this one goes down. And you'll notice that disturbance of people moving up and down traveled all the way from one side to the other. But each individual person only went very briefly up and down. In fact, the motion of each person was up and down. In other words, a person's motion was this way, while the disturbance moved to the right. So the actual motion of the people was perpendicular to the motion of the disturbance. That makes this what's called a transverse wave. Up, up, down, up, down, down, up, down. We can see the wave traveling, even though each person only moves very slightly. Another kind of wave would be if all these people were standing in a line, and this guy's at the front, and suddenly he moves to the right, then the next one can move to the right, then the next one, the next one, the next one, the next one, all the way to the end of the line. You'll notice in this case, each person is moving to the right, the disturbance moved to the left, but those are still along the same line. That's known as a longitudinal wave, and we will talk more about that in a moment. There are three main types of waves that we can expect to deal with in physics. The subject of this particular chapter is mechanical waves. We're going to mostly focus with transverse mechanical waves, but all mechanical waves will be touched on somewhat. That's where you have a physical object that moves up and down or sideways, but the actual material does not go very far, but the disturbance does. Then, later on, we're going to talk about electromagnetic waves. These are oscillations of electric and magnetic field that propagate through space and can in fact propagate through totally empty space. Last, we'll talk about matter waves. When we get to quantum mechanics, we will learn that even regular objects that we think of as material massive objects have waves associated with them that determine their microscopic behavior. So those are matter waves.